Hi students. So today I'm going to discuss with you paper which was conducted today in class. It's a subjective paper as per school level exams. Question number 1, information based. We have to pick up species. This question is regarding this passage is designed from S block elements. Question number 1. We have to pick up an element, metal, which on burning in air forms these products. When burnt in air, it forms oxide as well as nitrite. Right? Now, how to check it? Excuse me. Students, I need to identify an element, metal, which when burnt in air form these products. If you recall, among all alkali metals, lithium is known to show this property, exceptional behavior, and that shows a diagonal similarity with your all magnesium, all alkaline earth metals. So in that context, we can pick it up. This metal is lithium, and any of your alkaline earth metals. Right. So that way, so we can pick up. There are 4 options. Options are lithium and sodium. Optional lithium and sodium. Your options are lithium and magnesium. It is lithium only and beryllium only. So we will go with option second part. It's lithium and magnesium. So our next question is which right here. Question number 2 is like certain S block metal nitrate on decomposition formed metal nitrate with liberation of oxygen gas. This equation is not balanced. It's not a balanced reaction. This information given to us. Now, which S block metal seems to form such nitrate? Now, if you see the among all alkali metals, lithium nitrate shows an exceptional behavior. It decomposes forming oxide, NO2 with liberation of oxygen. Right. It shows diagonal similarity with magnesium, and all alkaline earth metal nitrates, they follow similar trend. Balancing is we can do later on. So that way, this metal was alkali. It was alkali metal nitrate, which may be sodium nitrate, except lithium. It may be potassium nitrate. It may be rubidium nitrate. It may be a cesium nitrate. That way, option we can pick up one of these is you. So you have 4 options. Is it nitrate of lithium? Is it nitrate of sodium? Is it nitrate of magnesium, or all of these? It will be picked up as nitrate of sodium. Let's move further. Next question is, which S block metal is used in formation of photocells? What are photocells? When light falls on these cells, they lose electron, and that electron shows conducting properties. So that way, we can pick up that metal as to be used in photocells, which has very low ionization energy, which is a high electropositive metal. So pick up a metal, the lowest ionization energy. In fact, all alkali metals can be used for this except lithium, but most appropriate is alkali metal with the lowest ionization energy. Options are lithium, sodium, potassium, beryllium. The best option will be your potassium. 4th part. In first question, 4th part, you are provided with alkaline earth metal carbonates, which decompose forming metal oxide with liberation of carbon dioxide. Now, information given to us is there's certain alkaline earth metal carbonate which decomposes as per this reaction, and the product form it gives crimson red color in flame test. Now, beryllium it gives no color, low energy, small size and very high energy. You would say magnesium it gives no color. Calcium In its compounds, it produces brick red color. Strontium, it gives a crimson red color. The strontium. Barium, it gives a apple green color. So it is picked up to be, as per options, your strontium carbonate. Right. So let's move further. The second passage. Second passage is regarding your P block elements. And what was the basic information given to you in this passage? These P block elements, if we compare the general properties, they show variation in their properties. And how this variation comes in? Because of poor shielding effect. In P block elements, boron family and carbon family, before valence shell configuration, you will see placement of D subshells. Right? In some elements, you will see F subshell in one element, the last element. Right? So due to the poor shielding effects, the force attraction valence shell increases, due to which this certain anomalous properties, behaviors are observed. So that way this passage was designed. Now question number 1, as per this passage is, these are ions provided to us. Right. First part, I have to identify which ion has ability to disproportionate. Right. Now let's see. This belongs to boron family. Boron, aluminium, gallium, indium, thallium. It's a second last element. Indium. It does not show anything by name as an inert pair effect. So in that context, it forms stable oxidation state +3. So this is highly unstable, right? This is a stable form. So indium +1, it will readily get oxidized. It will be it will get oxidized, and being unstable, it may get reduced also. Germanium +2, excuse me, I'm so sorry. Here I've given you indium 3+ as per options. So it is already stable. So it has no ability to get reduced. So that we ruled out. This germanium is an element of carbon family. Carbon, silicon, germanium, tin, and lead. So germanium, this seems to be a third element. Carbon, silicon, germanium. It doesn't show any inert effect. In this family, it is shown by lead. The germanium is more stable in oxidation state +4. So it will readily get oxidized. So being unstable, if it gets oxidized, so as if nothing else is present, having ability to reduce, simple half fraction is not visible. If germanium is getting oxidized, it itself will get reduced. So this will have ability to undergo disproportionate reaction. And in last option, we have thallium charge +1. Now thallium, it's a last element of boron family. So it shows inert pair effect. So because of inert pair effect, it is highly stable as such. So as it is highly stable, it has no ability to get oxidized. So still, it cannot disproportionate. The we will mark an option as a germanium charge +2. Right. So, moving to next picture. Next part. It was second part. We have to pick up the incorrect comparison of size, atomic size, among elements of boron family. Carbon, silicon. Silicon with a comparable size to germanium. Germanium having comparable size as tin. Tin having comparable size as lead. Among these, which one is incorrect comparison? We have to pick up that. Let me format elements of carbon family, germanium, tin, and lead. Valence shell is screened by S subshell. Valence shell is screened by S subshell, P subshell. Valence shell is screened by D subshell, F subshell. So due to poor shielding of D subshell in germanium, valence shell gets more strongly attracted. So that way, this germanium shows decrease in size, and size becomes smaller from its expected value. So these two, they have comparable size. Right. So that way, this comparison is correct comparison. Way to pick up incorrect comparison. top to bottom size of atom increases due to increase in number of shell. So this is absolutely correct comparison. Right. Now, in germanium, valence is screened by desorption. Tin is also screened by desorption. So as in both of the cases, the valence is screened by identically by desorption. So screening will remain almost comparable. So as screening remains almost comparable, so there will be a periodical trend. So periodical trend means top to bottom size increases. So atomic size of tin would be appreciably larger than that of germanium. So that way, this comparison seems to be wrong. So we have to pick up incorrect comparison. This is absolutely my right choice. Again, it is in tin. Valence is screened by desorption. Valence is screened by absorption. F has a poorest possible shielding effect. The poorest shielding, atomic size of lead will show a maximum decrease that becomes almost comparable to that of tin. So again, it's a right comparison. So incorrect comparison is this part. Right? Let's move next question. Now, next question is, this was designed slightly in terms of applications. This is electrode potential, E naught. Not exactly in core NCERT curriculum syllabus, just as the application was designed. This means ability to undergo this reaction. Right? So I have mentioned in statement the magnitude, the value of standard electrode potential, this electrode potential, corresponds to ability of ion to get reduced. जितना ज्यादा इलेक्ट्रोड पोटेंशियल होगा उतनी ज्यादा ability होगी reduce होने की and vice versa. First is for aluminium. This one is quoted to be minus 1.66 volt. As per data. For gallium, it is reportedly minus 0.56 volt. For indium, it is minus 0.34 volt. And for thallium, it is reportedly plus 1.26. So ABC as a number line, this has largest possible value, maximum value. So do you have an answer? Which trivalent metal line will show maximum ability to get reduced? So the answer will be thallium charge plus 3. So which will have minimum ability to get reduced? Aluminium charge plus 3. Right? So in that context, which answer will be D part, thallium charge plus 3. Now, fourth part of this information-based section, fourth part. These are the various elements of boron family: boron, aluminium, gallium, indium, and thallium. Right. Now these elements are to be arranged in the correct order of the ionization energy. Down group ionization energy decreases, but if you pick up size, gallium has atomic sizes smaller than expected. Similarly, thallium. Overall, all these three elements, their atomic size smaller than expected due to poor shieldings. So that way, as in gallium, atomic size becomes smaller than expected, it becomes comparable to aluminium. So due to increase in effective nuclear charge, ionization energy of gallium becomes slightly more than that of aluminium. It is a regular periodical trend, so definitely down group ionization energy decreases as screening remains nearly comparable. Now, there is a maximum decrease in size of thallium due to inert pair effect, so there will be abrupt increase in ionization energy. Gallium is screened by desorption. Indium is screened by desorption. So as screening becomes comparable, so there will be a regular periodical trend. So gallium to indium, we are moving downward, and downward ionization energy decreases. So that will be correct comparison. That option which will mark will be B part. I'm sorry, delta part. So it will be taken as a correct option. Right? Now these are two information-based questions. Now from here, moving to next. So let's continue next. Now, question number 3. In this question, number 3, you have to, question is that you have been given with 3 structures, getting structures, and their names are being mentioned. We have to pick up that option in which for a given structure, correct IUPAC name is written. So let's see these structures. A part, CH3, C double bond O, CH2, CH2, COOH. The ABC is expected name. Carboxylic is principal function group. Ketone is a substituent, less preferred function group. And carboxylic being terminal, this way we'll do its numbering. So its name will be 4-keto, or you may write oxo. Right? Anyone? Pentanoic acid. And exactly same name is given in option number 1. So this is acceptable. B part. Compound is this. It's IUPAC. Now, there are 2 ways to present this compound as per IUPAC system. Number 1, methyl. Once clubbed with the benzene, it may be read as a parent compound toluene. It may be read as a parent compound toluene. So as methyl is clubbed with the parent, and none of these are function groups, neither chlorine nor NO2 preferred function groups. So clubbing methyl with the benzene will be read as a toluene. Carbon number 1, 2, 3, 4. 4 chloro, 3 nitro, toluene. This is one way. As there is no functional, so there can be slightly another way also to pick up same compound. So other system would be for this. हम इसको बच्चों compound का naming कर सकते हैं ये 1, 2, 3, 4. So optional we can have another name also. 4 chloro, 3 nitro. I'm so sorry, but you have to arrange it alphabetically. 4 chloro, 1 methyl, 3 nitro benzene. Right. So as per statement, you have been provided this name. So this is once again acceptable name. The third option is, in this case, C part. The compound given to us is, it is CH3, CH2, twice CH, CH3, CH2, CH3, CH3. That's a compound. Third part. So I can expand this compound, and its expansion would give me the structure. Right? Now, some students, they may make mistake as a hasty step. This is alphabetically ethyl coming first. These are methyl as a substituents. By any ways, you can see this will be a longer chain. So we selected longer chain. Now I have to do numbering. For numbering, I told you there's a proper sequence for numbering of longer chain. First of all, we follow position rule, then lower sum rule, then alphabetical rule, then in case required numeric rule. Position rule is you will start numbering from that end from where desired characteristic group is nearest is placed at the nearest position. So if I start this numbering from left to right, so my first substance appears at carbon number 3. If I do numbering from right to left, my first substance appears at carbon number 2. And in this longer chain, characteristic presence is substituent only. So that way, as per position rule, this will be the correct numbering. This one. And groups are to be written in proper alphabetical order. The name will become 5-ethyl, 2,4 dimethyl, ethyl, methyl, methyl, and longer chain contains 7 carbons. heptane. So that way you can see all these names are correct, so that we will mark option as a D part. All are correct. Let's move to next question. Correct. Our next question is, this is phenylbutyrene. It undergoes hydration with 40% mercuric sulfate in present dilute H2SO4. What will be final product? This is pursuing through additional mechanisms, nucleophilic addition mechanism. It's a carbon-carbon triple bond. There will be addition of water. You can see a positive charge at start carbon. It will be considered as a benzylic carbocation. Positive charge at double start carbon will be simply behaving like a secondary cation. The benzylic is more stable. So that way, water will be added as per this mechanism. It is not stable, as OH group is on doubly bonded carbon. So to stabilize it, we should follow a phenomenon called as a tautomerism. And to avoid the tautomerism, I had given you people a trick in class. Re-added water here by several steps. So as a result, you would have two OH groups on same carbon, which is not isolable in aqueous solution or acidic solution. So it will lose water molecule. So finally, I would get this structure. This is trick. Actually, mechanism is tautomerism. So anyone among you who want to go through tautomerism, you may opt that part also. Now you see, you can see while removing this water, valency of carbon decreased by 1. Valency of this oxygen decreased by 1. So both of them can compensate the valencies by putting on a double bond. So that will be final major product. So in that context, answer will be marked as A part. Right? Let's move further. Next question is. Next question. Question number 4. Number 4. Sorry, number 5. This is number 4. You are provided with 3.2 grams methane. And you have to make it out. You have been provided data in 3 options. So you have to mark up, and 4th option is all of these. Let's do analysis data. As for options, you're asked to calculate number of molecules, number of electrons, moles of carbon as well as hydrogen in 3.2 grams methane. Methane is molar mass 16. So this 3.2 grams will amount to 0.2 moles. So that way, number of molecules 0.2 times Avogadro's number. Right? So you can make out some approximate calculations. It will be approximately 0.2 into 6.02 into 10 to the power 23, approximately 1.2 into 10 to the power 23. Right? Second is regarding electron. If you see, one molecule of methane contains 1 carbon and 4 hydrogen. As per atomic number, 1 carbon has 6 electrons and hydrogen has 1 electron each. So one molecule has 10 electrons. So if one molecule has 10 electrons, so many molecules will have how many electrons? So these number of electrons will be 10 times the number of molecules. So that it will become 10 times this number. So that is B part given to you. Option 3 is you have been provided with amount of carbon as well as hydrogen. If you have a look once again, one molecule of methane contains 1 carbon and 4 hydrogens. The number of carbon atoms in methane same as the number of molecules of methane. So that way, 1 mole methane contains 1 mole So you are providing 0.2 mole methane. So therefore, 0.2 moles methane. It will contain 0.2 mole carbon. And you can see which one molecule of methane contains 4 hydrogen atoms. So that means 1 mole of methane. It contains 4 mole hydrogen. So 0.2 mole methane, it would contain 0.8 mole hydrogen. So that way, all calculations given for are correct. So that way, answer will be marked as a D part. Right? Check. Let's move further. Next question is radius of, this is question number 6. Radius of first excited state of hydrogen atom. As hydrogen contains only 1 electron, as it contains only 1 electron. So we can make out this calculation by using Bohr's formula. A radius of n shell is 0.53 into n squared by z, so many angstroms. First excited state. What is excited state? A state in which electron comes after absorbing certain amount of energy. It is called as excited state. So if these are considered as various shells, first shell, second, third, fourth, fifth. Hydrogen has only 1 electron. So that will be its most stable arrangement. Right? This electron can be taken to second shell, third shell, fourth shell, fifth shell by providing appropriate amount of energies. So electron will come to second shell or third shell or fourth shell or fifth shell after absorbing certain amount of energies. So that way, second, third, fourth, fifth, they all will be called as an excited states. And where it will be present without absorbing any energy? First shell. So this is called as a ground state. Rest all will be taken as excited state. So what will be first excited state? Second shell. So that way, for hydrogen, its nucleus contains 1 proton. So that means Z value will be 1. And N will be 2 as it is first excited state. So radius will be into 4. So many Armstrong. Absolute answer. Right? Okay. Let's move next question. Next question is, there is an aqueous solution whose pH is 2 and it is changed to 3. So what will be correct regarding this change? You can see which pH is less than 7, so this is something about acidic solution. As pH is minus log, H plus n molar concentration, that is pH. So if pH is 2, that means H plus n concentration will be 10 raised to the power minus 2. Right? It is changed to 3. Now H plus n concentration has become 10 raised to the power minus 3. So from 10 raised to the power minus 2 moles per liter, it has changed to 10 raised to the power minus 3 moles per liter. हम इसे थोड़ा सा और सिंपल करके देख लेते हैं. It has changed to 0.001 moles per liter. Right? So that you can see the concentration has decreased. Right? Okay. Concentration of H plus ion in initial case. Concentration of H plus ion in final case. Initial case it is 10 to the power minus 2. Final case it is 10 to the power minus 3, which will be 10. So that means initially बच्चे H plus ion की concentration 10 times की final concentration की. So that means जैसे हमने ये change किया तो ऐसे करने से H plus ion concentration 10 times 10 गुना decrease हो गई. Right? So accordingly we can pick up its options. But A part is H plus ion concentration has become 10 times. No, it has decreased 10 times. Second, it has become 1/10. That is decrease 1 time, right? So B part will be taken as a right option. Right? Next question. Question number 8. This is question number 8. Now, you're given with certain species, nitrate, NO2 positive, NO2 negative, and ammonium cation. These are to be arranged in correct decreasing order of bond angles. जब आप bond angle comparisons करते हो, आपको बच्चों ने क्लास में 3 planets प्रोवाइड किए थे, 3 cases. Number 1, if they have a different set of hybridizations, you can see. So in that manner, as orbitals and hybrid set increase, bond angle decreases because as per Western theory, सेंट्रल एटम के अराउंड जितने इलेक्ट्रॉन पेयर्स होंगे वो यूनिफॉर्मली अरेंज्ड होंगे सो एज टू मिनिमाइज रिपल्शन. अगर सेंट्रल एटम के अराउंड 2 इलेक्ट्रॉन पेयर्स हैं या हाइब्रिड शेड इज sp, तो दे विल बी अरेंज्ड एट एंगल ऑफ 180 डिग्रीज. तीन होंगे तो 120 डिग्री पर. तो लाइक जैसे नंबर ऑफ ऑर्बिटल हाइब्रिड शेड में बढ़ेंगे बॉन्ड एंगल विल डिक्रीज. नंबर 1. नंबर 2, वेस्पर थ्योरी हैज कोटेड अस अगर एक ऑर्बिटल में शेयर्ड इलेक्ट्रॉन है, जस्ट अगर एक ऑर्बिटल में शेयर्ड इलेक्ट्रॉन है and one orbital contains lone pair, so in that manner you can see the orbital containing lone pair has a larger density than orbital containing shared pair. तो फिर हमारा वहां पे सेकंड केस ये आया था कि अगर आपके पास कुछ केमिकल स्पीशीज आती हैं जिनमें हाइब्रिड शेड सेम है बट नंबर ऑफ लोन पेयर्स अराउंड सेंट्रल एटम आर डिफरेंट, तो ऐसे केसेस में लोन पेयर के बढ़ने से बॉन्ड एंगल यूजुअली डिक्रीज होता है. इनफैक्ट ये हर केस में डिक्रीज होता है विद वन एक्सेप्शनलिटी, sp3d 3 लोन पेयर्स. अगर sp3d हाइब्रिड शेड में आप लोन पेयर्स बढ़ाओगे 1 2 एंड यू मेक इट 3, वो तीनों लोन पेयर्स इक्वेटोरियल पोजीशन ऑक्यूपाई करेंगे जिससे वो एंगल बन जाएगा 180 डिग्रीज नॉर्थ का. दैट इज वन एक्सेप्शनलिटी, अदरवाइज इट डिक्रीजेस. और तीसरा केस में हमारा ये था अगर हाइब्रिड शेड भी सेम है, नंबर ऑफ लोन पेयर्स भी सेम है, देन वी सी बॉन्ड पोलैरिटी. मान लीजिए एटम A B, central atom A C. Let's assume electronegativity of B is more than that of C. Okay, electronegativity B की C से ज्यादा है, and electronegativity of A is largest among these all. So in AB bond, shear pair will be towards A. As C has least electronegativity, this shear pair will be very close to it. तो हमारा थर्ड केस था, जैसे जैसे शेयर पेयर सेंट्रल एटम के नजदीक मूव करेगा उसमें जैसे जैसे डिस्टेंस कम होता जाएगा तो शेयर पेयर में रिपल्शन बढ़ेगी और उस रिपल्शन को डिफ्यूज करने के लिए एंगल्स हैव टू मूव आउटवर्ड्स टू मिनिमाइज दैट रिपल्शन. तो जितना शेयर पेयर टुवर्ड्स सेंट्रल एटम माइग्रेट करेगा बॉन्ड एंगल उतना ज्यादा रहेगा. राइट, ये है हमारा प्लान ऑफ इस क्वेश्चन का. नाउ लेट्स सी, do we record all these 3 cases or not? मैं सबसे पहला काम बच्चों की हाइब्रिड से निकालूंगा. sp2 0 lone pair, this is sp no lone pair, this is sp2 it contains 1 lone pair, this is sp3 it contains 0 lone pair. तो as per case 1 मैं हाइब्रिड सेट से शंटिंग करूंगा. NO NO2 negative, NO3 negative, greater than NH4 positive. Now, this contains 1 lone pair. It is 0 lone pair. So, with the increase in lone pairs, repulsion will increase. That way, this is a lone pair बढ़ेंगे बच्चे बॉन्डिंग कम होता जाएगा तो हमारा परफेक्ट ऑटो बनेगा ये. NO2 negative and then NH4 positive, right? Arrange. So that way its option will be marked accordingly. It will be B marked. Right. Okay, students. Let's move ahead for discussions. Right. What will be next question? Next is regarding correct. You have been asked to mark correct uh, order regarding these are species provided to you. These are some species given to us, and these are to be arranged. Means we have to identify the correct order regarding decreasing order in terms of bond dissociation energy, oxygen-oxygen bonding, and bond order. All these terms they can be very well related to bond order calculation. See, now regarding bond order calculations, while in chemical bonding, I had given you people a trick to calculate bond order. And what the trick was, in case atomic species molecular species contains more than 8 electrons. So whatever is the total number of electrons, subtract 8 out of that. The total number of electrons, subtract 8. Right? And after subtracting 8, how many electrons are remaining? How many electrons are remaining? Among those, 6 will be considered as bonding and rest will be taken as an anti-bonding. So let's see the number of electrons first of all. O2, oxygen is topic number 8. So O2 contains 16 electrons. Plus 2 means loss of 2 electrons. So it will have in total 14 electrons. O2 charge minus 1. O2 16 electrons and minus 1 charge means gain of 1 electron. So it becomes 17 electrons. Likewise, it will be 15 electrons. This will be 16 electrons and this will be 18 electrons. So let me get the bond order. Bond orders, number of electrons in bonding minus number of electrons in anti-bonding molecular orbital divided by 2. 14. Among 14, subtract 8. Remaining will be 6. All 6 will be bonding. So there is no anti-bonding, so its bond order will become 3. 17. Subtract 8. Number left will be 9. Among 9, 6 will be bonding, 3 will be anti-bonding. So 6 minus 3 will be 3. 3 by 2 is 1.5. 15. Subtracting 8. Number would be 7. So among 7, 6 will be bonding and 1 will be anti-bonding. So 6 minus 1, 5. 5 by 2 is 2.5. 16. Subtracting 8. Number left will be 8. Among 8, 6 will be bonding, 2 will be anti-bonding. Difference will be 4. 4 by 2 will be 2. 18. After subtracting 8, number operator will be 10. Among 10, 6 will be bonding, 4 will be anti-bonding. So 6 minus 4, 2. 2 by 2 will be 1. So regarding bond order, correct order is O2 charge plus 2, O2 charge plus 1, O2, O2 charge minus 1, O2 charge minus 2. Now, bond order basically determines strength of bond. What quantum mechanically bond order is? Number of shared electrons per atom in a bond. The larger the bond order, more will be number of shared electrons. More the number of shared electrons, stronger will be attraction. The stronger the attractions, stronger will be the chemical bond. So bond strength, bond dissociation energy are directly proportional to bond order. So that we will achieve. As the first option, you have to quote the decreasing order bond dissociation energy. As bond dissociation energy is directly proportional to bond order, it will be the same order. Next is regarding your oxygen-oxygen bond length. See, these are two atoms which have made a bond. If these two atoms are very strongly attracted, so they will come more closer to each other. So as bond strengthens, atoms come closer to each other, hence the length decreases. So bond length is inversely proportional to bond order. Right? So that you can see which the trend. So bond length will be its inverse order. O2 charge minus 2, largest bond order, then O2 charge minus 1, then O2, then O2 charge plus 1, then O2 charge plus 2. That will change. The answer to be marked is D or all of these are correct. Right. Let's move forward. Correct. Now, next question comes up to be There are two separate verbs, right? This verb contains gas A and another verb, it contains gas B. The two verbs containing gas A and B. Now, as per statement, density of gas A is twice the density of gas B, as per data. Molar mass of A is half of molar mass of gas B. So I have to calculate pressure exerted by gas A and pressure exerted by gas B. What will be their ratio? When both of these gases are kept at same temperature. Now, using ideal gas equation, density is calculated as Pm by RT. So you can see which is simply, it's a comparison based numerical. Being comparison based numerical, R is gas constant, temperature remains same, so VA by VP, PA into MA, PB into MB. So I can put up all these credentials. Density of gas A is twice of gas B, PA by PB. Molar mass of gas A is half of that of B. So this calculation will be 1 by 2. The solving it, this ratio will be 4:1. Okay, check. Let's move next. Question number 11. Now, what that question is, number 11. It is certain chemical process in which delta H stands to be 125 kilojoules per mole and delta S stands to be 115 joule Kelvin inverse mole inverse. You are then given 4 options with respect to temperature. I have to pick up at what temperature reaction will be spontaneous. One option is 400 Kelvin. Second option is 1100 Kelvin. Third option is 800 Kelvin. And fourth option is 273 Kelvin. One of the procedures, trying these options individually, get delta G in each case. Wherever delta G becomes negative, that will be the right answer. But that will be too lengthy. Means in one question, you will be solving like 4 questions. So it will take too much time. Second part is, I know reaction is endothermic and has a positive entropy change. So gives free energy state. Remember this? So as for these credentials, I can make it a condition in terms of temperature and this process becomes endothermic. And this process becomes spontaneous. Now, once I put up these credentials, there will be no change in sign. Now, under what condition delta G will become negative? When this magnitude exceeds this magnitude. Clearly you can see. तो इसमें डेल्टा जी बच्चे नेगेटिव सर तभी आएगा जब आप ये कंडीशन पोज करोगे. तो मैं इस कंडीशन देख लेता हूँ कि टेम्परेचर हमारे पास क्या है. So temperature seems to be greater than 125 kilojoules per mole. 115 joule Kelvin inverse mole inverse. Right. Now, if you solve it directly, it won't be dimensionally correct. Kilojoules, joules. Right? Here a common mistake है. You have to be careful about it. So we can convert kilojoules into joules. Here solve for the check. And that will give you answer. So accordingly, this will be right answers. Okay, next question, number 12. What is this next question to be cracked out? You have been given set of quantum numbers, and we have to point out in which case the set of quantum number is not correct. Right? So first option is n equals 3, L equals 2, M equals -2, and S equals -half. B part n equals 5, L equals 0, M equals +1, and S equals plus half. Third part, N equals 4, L equals 0, M equals minus 1, S equals minus half. And D part, N equals 1, L equals 0, N equals 0, S equals minus half. So as per syllabus, you can clearly see absolutely correct, because the value of L is a set of integers starting from 0 going up to n minus 1. The value of m stands to be minus L to 0 to plus L, set of integers. S can have value plus L and minus of 1. Set 1 is absolutely correct, there is no mistake. Set B has a mistake. Why? If L is 0, m cannot be plus 1. If L is 0, m has to be 1. That set is giving wrong information. Excellent. Even this set gives us a wrong information. If L is 0, m cannot be minus 1. So these are two the options in which set is not correct. So that way, answer mark कर सकते हो both B and C. Next question. Next question. You have been given species I2, O3, IO4 charge minus 1, I2, I charge minus 1. I have to pick up an option in which all these species are arranged in decreasing order of oxidation state of iodine. Doing the mathematical calculations, it will be plus 3. This oxidation state will be plus 7. This oxidation state will be 0, and this is minus 1. So in numbers को बचे number इनके हिसाब से arrange कर सकते हो. तो correct order बनेगा ये. That will be absolutely correct. Let's move next question. In question number 14, it's a simple question. You have been given Boyle's law, Charles' law, Dalton's law, and Gay-Lussac, Charles' law. This is column 1, and column number 2, the credentials are given. So we have to match the content of column 1 and column 2. What does Boyle's law state? For a given amount of gas, right? Volume and given temperature, volume is inversely proportional to pressure or converged. Pressure is inversely proportional to volume. What does Charles' law state? According to Charles' law, for a given amount of gas, at constant pressure, volume is directly proportional to absolute temperature. What is Dalton's law? If you have a mixture of two or more gases, we do not chemically react. Total pressure will be always equal to sum of pressure of individual gases. So that's from the other perspective. What is Gay-Lussac's Charles' law? This states that pressure of gas is directly proportional to temperature. So, अगर आप gas की heating करोगे, molecules will become more energized. They would exert high pressure, provided we don't change volume of container. तो आप ये बच्चे कंटेंट समझ कर सकते हो. Next question. Number 15 and 16. These two questions were basically reason assertion based problems. So you had instructions. Both assertion bases are correct, and reason is correct explanation of assertion. Option A. Both assertion bases are correct, but reason is not correct explanation of assertion. Option 2. Assertion is correct, reason is incorrect. Right? Assertion is incorrect, reason is correct. Right. Now, question number 15. Enthalpy of formation of HCl is equal to bond energy of HCl. This is not at all acceptable, okay? Formation of HCl, it will be this reaction. Okay. So this is not equal to bond energy. Actually, this enthalpy of formation, it will be half of bond energy of H2 plus half of bond energy of Cl2 minus bond energy of HCl. It will be this simple. So that way, assertion is absolutely wrong. Reason which is enthalpy of formation involves energy released or absorbed during formation of one mole HCl from its respective elements in standard shape. The reason statement is proper definition of enthalpy of formation. So assertion is wrong, reason is correct. Hence combination picked up is your C part. Question number 15. Number 16. Number 16. And this will end up on section 8. Enthalpy of hydrogenation of transalkene. This is trans and this is cis. Again, it is regarding enthalpy of hydrogenation. जो enthalpy of hydrogenation है मुझे delta H hydrogenation. This is inversely proportional to stability of alkene. Alkene जितनी ज़्यादा stable होगी, उसकी enthalpy of hydrogenation उतनी कम होगी. And vice versa. These are the bulkier alkyl groups. In transalkene, they are kept almost diagonally opposite. And right hand says they are on same side. So being at minimum distance, there will be certain amount of repulsions. तो उस repulsion के कारण potential energy बढ़ेगी इसके वजह. तो potential energy ज़्यादा होने के कारण it will be relatively less stable. So that it will be more stable. इसलिए enthalpy of hydrogenation of cis isomer will be more than that of trans isomer. That is so assertion statement is wrong. Reason is transalkene is relatively more stable than alkene. Both take a so assertion wrong, reason correct. So that way it will be marked as your B form. Right. This ends section 8 of your test. Right. So एक बार सब डिवाइड करो फिर बाकी लोग बात डिस्कस करते हैं. Okay बच्चों, take care, all the best.